In section 4.5c, we're now going to look at phase shifts and vertical displacement for both sine and cosine functions. So we're going to look at the same transformation with both parent functions. All right, so we still have A, where the absolute value of that number is the amplitude. B is 2 pi over B gives the period. And now, inside my parent function, we have plus or minus C, which is the phase shift. Okay, so really this is y equals whichever trig function we were looking at. All right, with A, and then we have B, and it is x minus C. So if I have a negative number in there, so minus something, it is actually a shift to the right. If I have a positive number, that means I subtracted a negative, so that means it is to the left. So it's a little bit the opposite of what you feel like it should be with the sign inside the parentheses, okay? The sign of that number that's added or subtracted. So let's break this apart. For example 1, my amplitude comes from A, which is 1. There is no reflection. My period is affected by B, but there's nothing there. So my period is still 2 pi. And my phase shift, it's a positive, so it was minus a negative. So my phase shift is pi over 2, and so that is to the left. Okay? So, all right, this is cosine. So my period hasn't been shifted, so I know that normally what would take 2 pi to complete a cycle, it still does, but now everything is shifted by pi over 2 to the left. Okay, so pi over 2 is this one here, so I'm going to shift every single point to the left by 2 boxes. Okay, so now my maximums happen at negative pi over 2 and 3 pi over 2, and then halfway in between those is pi over 2, so that's where my minimum happens. Okay, and then at pi and at 0, I have zeros. Okay, and then that pattern would repeat. Okay, and in this case, I'll do 2 periods. All right, and so now I have my key points, and I can sketch my graph. In our next example, our parent function is sine. All right, and my amplitude is 2. My reflection does not exist because there's no negative sign out front. The period is going to be 2 pi divided by 1/2, which is 2 pi times 2 over 1, or 4 pi. Okay, and my phase shift is pi over 2 to the right. Okay, so normally sine would start at the origin, but, all right, now that's going to be shifted pi over 2 to the right. So now my graph starts at pi over 2, and my period takes 4 pi. So I'm going to go 4 pi from there, okay? So I can also think about the end of the period being phase shifted to the right by pi over 2, okay? So that's a full period. I know that halfway between those, I will have another 0. Okay, so between 1 and 9, halfway is 5, pi over 2. And then normally, the next thing I would do is to put my maximums and my minimums halfway between my zeros, going up first, unless I have a reflection. But in this case, my amplitude is 2, so I need to make my maximums at 2 and my minimums at negative 2. Okay? And actually, sorry, that original minimum should have been there. So now I have a full period of my function. Okay, and this would continue, but here there's really only enough for one full one, and then it would just kind of continue. All right, we're going to skip to example 4, just so we can see what it looks like when we have an amplitude change, so we have a vertical stretch by a factor of 4. Still no reflection, all right, but our period is going to be 2 pi divided by 1/4, all right, or 8 pi, and our phase shift is pi to the left. Okay, so our parent function is sine, so I know I want to start at 0. Okay, so my parent function would be 0, and then a full period later, okay, so 8 pi later, I would be back at 0. So let's count, let's make every box as pi, so every other one we can label. So 8 pi is here. Okay. And then our amplitude, okay, normally it would be 1, but now I have 4, so I need to fit 4 vertically, so we'll go 1, 2, 3, 4, -1. Okay, so we'll plot what initially would have been my points, all right? So I would have had at 0 and 8 pi, I'll have zeros, and then halfway. Now, those aren't going to change other than they're going to get shifted left by pi. So in this case, pi is a single box. All right, so each one gets shifted left by a box. Okay. Again, my maximum would have happened at 2 pi. So now it's just 1 less than that. So it's 1 pi less than that, so at 1 pi. And then my minimum would have happened at 6 pi, but I'm going to move left by 1 pi, so it happens at 5 pi. So I still have a sine function, all right, that starts its period at 0, ends at 0, goes up first because there's no reflection, and then crosses through a 0 to a minimum, takes 8 pi, but it's now been shifted left, okay? And then those minimums and maximums were just stretched vertically. And now we get our final transformation, all right, for our trigonometric functions of sine and cosine, all right? And I actually like to write these in the form of y equals a sine, all right, bx minus c, and then plus d, and y equals a cosine bx minus c and plus d. Even though this says plus and minus here, all right, if you remember that it's minus c and plus d, it helps you figure out which direction you move your graph. All right, so a is still the amplitude, and a negative sign would tell me it's a vertical reflection. 2 pi over b still tells me the period. C is a horizontal translation, and d happens at the end after I've done all of the function, all right, and I've multiplied everything by my amplitude. So d does not change my amplitude, just takes the whole graph, all right, and shifts it vertically up and down, okay? So for sine of x plus 2, all right, my amplitude hasn't been affected. There's no reflection. The period is 2 pi divided by 1. There's no phase shift, but my vertical displacement is plus 2. So while my initial graph, all right, starting at 0 and going to 2 pi, would have had a 0 halfway through, maximum, minimum, all right, and repeated. But in this case, I have a vertical displacement of plus 2. That is the only transformation. So every single point here is going to go up by 2. So what was a 0 now becomes 2. Okay, my maximums were 1, but now I'm going to add 2 to those. So from 1 plus 2 is at 3. And my minimums are now going to be up 2 from where they were. So -1 plus 2 is +1 is now where my minimums occur. Okay, so I have enough of my key points. That I can sketch, okay? And I know it's not pretty on the iPad, but you can still see that my amplitude is 1, okay, from where my zeros were, okay, or from where that 0 line has moved to, okay? For the sake of brevity, we're not going to do every single example, but I'll try to do some of the ones that are a little bit trickier. So on that note, we're actually going to look at example 7 because this one has a vertical reflection. The period is 2 pi divided by 1/2 or 4 pi. There is a phase shift to the left by pi over 2. There's no vertical displacement, all right? And my amplitude is still just 1, but now I've got 3 things. I've got a reflection, a changed period, and a phase shift, okay? And we're looking at cosine as our parent function, okay? So normally cosine would start at 1, at 2 pi. I would have another maximum halfway in between. I'd have a minimum, all right, and then my zeros. But now my period has been stretched, okay? So instead of having my next maximum after 0 at 2 pi, it's now at 4 pi. And halfway in between, I now have I have a minimum. But I have a reflection. So what was a maximum now becomes a minimum, and vice versa. Okay, and actually that point was in the wrong spot. So now I've got my reflection. All right, I've taken care of the period. I've taken care of the reflection. Haven't changed my amplitude. Don't have vertical displacement, but I have to phase shift. So every single one of those points, all right, and it might help if before we shift things we put in our zeros halfway in between our maximums and our minimums. Okay, so every single one of those points is going to get shifted left by pi over 2. Okay, and these are that one's 0.5 instead of negative pi over 2, but same thing. Okay, so every single blue point here is going to get shifted left, okay, to be red. Okay, and so I would have another 0 there. Okay, and so now I have my final graph. All right, I have an amplitude of 1. I have a vertical reflection, all right, and I've been shifted left by negative pi over 2. Okay, in our next example, we have to write an equation for this graph. So our two choices for our parent function are sine or cosine. Turns out you can actually do either because they're really the same shape, they just start at different places. But if at x equals 0, I have a minimum, all right, so sine usually starts at 0 at the origin, and then cosine is the one that starts usually with a maximum, but I can make it a minimum just by doing a reflection, okay? So I can do that, okay? So if I want to do this in cosine, all right, my period, when I get to the next minimum, it's still 2 pi, okay? So that means b equals 1. I have no phase shift, all right? And let's see, my vertical displacement and my amplitude. Well, my minimum happens at -2 and my maximum happens at 4. So that's no longer centered around the origin, okay? So I know I have a vertical displacement, and my amplitude is going to be half of that total vertical distance. So 4 minus -2 is 6, so half of that is 3. All right, and so my vertical displacement is going to be 3 down from 4, which is also 3 up from -2, so it is +1. Okay, so when I write this in cosine, it is y equals a. Cosine, all right, there's no b, so it's just x, no phase shift, and then +1 at the end. Now, if I wanted to do this for sine, there's going to be some similarities, okay? My amplitude is still 3, my period is still 2 pi, and my vertical displacement is still 1, but I'm going to have a phase shift, okay? So if I draw a line at my vertical displacement, all right, so that is where my graph is oscillating about. It's going above and then below and then above and then below, okay? So normally I would have a 0 at x equals 0, but now that is happening. It looks like that's at maybe pi over 2. So what that looks like, it's halfway between 0 and pi. So my phase shift, if I'm going to work in sine, okay, is it's pi over 2, but it's to the right, so I want a negative value, okay, in my equation. So when I put in c, okay, so it's going to be y equals still 3, but it's sine, okay, there's no b value, so it's x minus pi over 2, so I go to the right, and then at the end, +1. Oh, and I just realized that when we did our cosine, we needed to do a reflection, so there should be a negative sign in front. The last thing we have to do is write an equation, all right, based on the transformations described for each function. So if I have sine, like in 9 and 11, okay, my parent function, including all the possible transformation, is a sine b x minus c plus d. And in 10 and 12, it's the same thing except I replace sine with cosine. Okay, and now all I have to do is identify if I have A, B, C, or D, or if I have a reflection to put a negative out in front. All right, so let's look at number 9. So I have an amplitude of 3, so that is A. My period is 4 pi, so 4 pi equals 2 pi over B. So B must equal 1/2. And that's all I have, so C and D are not there. Okay, so I have y equals 3 sine, and then I don't need the parentheses because C doesn't exist and neither does D. All right. On number 10, I have an amplitude of 2, so that is A. My period equals 6. So some of our problems, especially on the homework, get a little bit tricky because now 6 equals, it's still 2 pi over B. But now, when I multiply both sides by B, I get B times 6 equals 2 pi. All right, remember I want to solve for B so I can put it into this equation. So I'm going to divide both sides by 6. So B equals 2/6 or 1/3 pi. So if B has pi in it, all right, our period is just going to have numbers, okay, instead of having pi. So that's our only other transformation other than the amplitude. So our answer is y equals 2 cosine. All right, and now x does need a coefficient, but there's still no c or d, so it's 1/3 pi x. In number 11, we have an amplitude of 2, so that's A. We have a reflection, so that's a negative out in front. And a shift left is C equals negative pi over 2. Okay, so remember when I subtract a negative, it becomes positive. So when I write my equation, it is negative for the reflection, 2 for the amplitude. Sine is my parent function. All right, and I need the parentheses because I have C. All right, I need to differentiate whether it's a C or a D. So it is x minus a negative, so plus pi over 2, close my parentheses, and D equals 0. In number 12, they tell me A equals 3. Up 4 means that D equals plus 4. Left 2 pi means that C equals minus 2 pi. And my period is 2. So 2 equals 2 pi over B, and so B must equal pi. So let's put that all together. So that is y equals, no reflection, but there is A, so 3 cosine. All right, B is pi, and so I have x minus, C is negative 2 pi, so plus 2 pi, and then at the end I've closed the parentheses, and then I add 4 to go up.